Okay, so we're looking at problem number 1 in your free response packet. And again, we're told that g of x is equal to the integral from 0 to x of f of t dt. So the first thing we have to find is g of 0. So if we recall, g of 0 is going to be the integral from 0 to 0 of f of t dt, which is 0, because anytime you integrate from a to a is 0. G of 1 is going to be the integral from 0 to 1 of f of t dt. And what we can see is that when we go from 0 to 1, what we've created is this nice little rectangle here. And so our area of this rectangle is simply 2, because it's 1 times 2. So that area is 2. We're finding the area under the curve, so that area is 2. Okay? Now we have to find g of 3. So g of 3 is now all of this area. So g of 3 is all of this. Oh, we have to find g of 2. Sorry, I skipped something. G of 2 is all of this. Okay, I can't make that any smaller. So g of 2 is the area from here forward. Okay? So what may be a nice thing to do is that I can break this into 2 areas. I already know that the area from 1 to 1, I already know that area is 2. So I can say g of 2 is equal to the integral from 0 to 1 plus the integral from 1 to 2. Okay? And we already know the integral from 0 to 1 is 2. Then to find the integral from 1 to 2, that is a trapezoid. So that would be 1/2 times the height. The width of this the height of that trapezoid is 1. This would be base 1. Erase that so you can see what I'm pointing to. This would be base 1, and that would be base 2. So that would be 2 plus 4. So g of 2 was going to be 2 plus 6, 3. G of 2 is equal to 5. So g of 3 is the integral from 0 to 2 of f of t plus the integral from 2 to 3 of f of t. Okay? We already know that that value is 5. So now we have to find the value from 2 to 3. So that is a triangle. So that's 1/2 times the base of this triangle, because this makes this triangle. So 1/2 times the base of that triangle, which is 1, times the height of that triangle, which is 2. So then I get 5 plus 2, and that's 7. So g of 3 is 7. So we have g of 2 is 5, and g of 3 is 7. Now to find g of 6, I have to remember that g of 6 is going to be the integral from 0 to 3 plus the integral from 3 to 6 of f of t. Okay? So I already know this one is 7. The other thing I need to notice here is that this area from 3 to 6 is negative because it's underneath the x-axis. So I can make this into into a triangle and a rectangle and find the area. So that area is going to be negative because it's underneath the curve. It's going to be 1/2 I was hoping it would do that. It would be 1/2 times the base. This base is 2 times the height, which is 2. You could say it's -2 and add. You can do it either way. Plus the area of this rectangle, which is 2 by 1. Okay, so this is 7 minus 2 minus 2. So that's 3. So G of 6 is 3. Okay, so basically that was just an exercise in finding the area under the curve. Alrighty, now they want to know on what intervals is G increasing. So in order to see where the function is increasing, we have to look at where G prime of x is greater than 0, because it's increasing when G prime of x is positive. So recall that G prime of x is equal to the derivative with respect to x of the function, which is 0x f of t dt. We can use the fundamental theorem of calculus on this because this is a constant and the x's are the same. So this is simply f of x. So what we're looking for is when G prime of x, which is equal to f of x, is greater than 0. And that happens here on this interval where G of x is positive. So that happens on the interval from 0 to 3. When does G have a maximum value? So G has a maximum value when G prime of x goes from positive to negative. Okay? So remember, G prime of x is equal to f of x. So where does f of x go from a positive to a negative? So it goes from positive to a negative at 3. So it's going to have a maximum value at x equals 3. They want us to evaluate G prime of 2. So G prime of 2, because G prime of x is equal to f of x, so therefore G prime of 2 is equal to f of 2. And f of 2, let's go to 2, f of 2 is 4. Just from the graph. When x is 2, y is 4. Find any points of inflection, justify your answer. So points of inflection occur when G prime of x, when G double prime of x goes from positive to negative, or when it goes from negative to positive. Okay? So we have to remember that G prime of x is f of x. So G double prime of x is f prime of x. So I'm looking at the derivative of this. So my derivative goes from positive to negative at 2. I know it's undefined there, but remember points of inflection can also be where the derivative is undefined. So this goes from positive to negative at x equals 2. Okay? Now, then it goes, it's 0 for a little bit, but then the derivative goes from, that derivative is negative, or 0 here, and then it goes positive there. So I'm going to say at x equals 2, and x equals 6. Okay. At x equals 6, it really didn't change directions because the derivative was 0 here, and then the derivative went positive. But somewhere or another it had to change directions here because the derivative went from negative to 0 to positive. So I'm going to say here as well. So find any points of inflection. I'm going to say x equals 2 and x equals 6. Okay, that's it for that problem. We'll do the next problem in a minute.